Hi all, today's topic is partial fraction for a problem 2. Find L inverse of 1 minus s divided by s plus 1 into s squared plus 4s plus 13. So first we have to take the inside question separate and write a partial fraction. When you have only single term s plus 1, okay, 1 divided by s plus 1, the partial fraction is nothing but a divided by s plus 1. But when you have the quadratic term, any quadratic term, 1 divided by s squared plus 4s plus 13, when you have a quadratic form, it may be any quadratic form. When I am able to write as the product of two terms separated, then you can write, it's easy, like a video 1. Okay, before video you check my previous video, inverse Laplace transform partial fraction, problem 1, you check it, I have written for that. Okay, so now it is the quadratic form. How we have to write the partial fraction? Bs plus c divided by the quadratic form, because I have square term, quadratic term. This a cubic term means bs squared plus cs plus d. This is the way you have to write it. Next order 4 means this is the way you have to extend it. Okay. So now when I write it, 1 minus x equal to, take a LCM, this right hand side also I am taking LCM, I get the solution. So now when I write it, 1 minus s equal to a into s squared plus 4s plus 13 into bs plus c into s plus 1. Now I am not going by a constant. For example, s equal to 0, s equal to minus 1 and some other variable s equal to 1. So when I have it like this, I may get a 3 solution directly, or I may get a 2 equation format. To solve that equation, you may get your coefficient a, b, c. So that method I have done in my previous video. Now I am not going with that method. I am going with another one more method. It is called as the quotient method. Okay, equation quotient method. For example, equating the quotient of x squared, equating the quotient of s, and equating the quotient of constant separate, we get a certain equation. Solve that equation, you may get the solution a, b, c. That only I am going to do in this problem. So before going with that, extend the equation so that I can find the x square, s term and constant term. So 1 minus s equal to a s square plus 4as plus a 13 plus b s squared plus cs plus bs plus c equal to, this is the equation. Now equate the coefficient of s squared term. S squared term means I don't have left. So 0 equal to s squared term, it is a. S squared term is b. A plus b equal to 0. So which is nothing but a equal to minus b I am getting. Okay, this is our first equation. Next, equating the coefficient of s. S when I equate it, minus 1 equal to s, where I have 4a, where I have s, c and b. B and C equal to 0. My second equation. Third equation will be a constant. Constant when I equate it in this equation. So constant I have 1. Constant where I have A 13 and C is our constant. So it is nothing but 1 equal to 13A plus C equal to 0. So this is our third equation. Solve all the three equations, we will get our ABC. So now when I solve it, in this when I solve a equal to minus b, so a equal to minus b, I will get substitute equation 1 in 2. It becomes, my fourth equation becomes new equation. Substitute a equal to minus b, mean minus 1 equal to a equal to minus b. Okay, so 4a as it is, minus b is minus a, so minus a plus c. So when I simplify it, minus 1 equal to 3a plus c I am getting. Okay, so 3a plus c I am getting the solution. Now what I am going to do, I am going to simplify the third equation and now new equation, fourth equation I am going to simplify it. Third equation and new equation I am going to simplify. So this is our fourth equation, this is our third equation. This both I am going to simplify it. So 1 equal to 13a plus c minus 1 equal to 3a plus c. So subtract it. So C get cancelled. So 10a equal to 2. So a equal to 1 by 5. A, if it is 1 by 5, we know that substitute in first equation, equation 1, I will get b to be minus 1 by 5. Okay, a and b calculated. Now I need to calculate c. C I can substitute in this. C is nothing but minus 1 minus 3a. A is 1 by 5. Take a LCM. So minus 5. So minus 5 minus 3 divided by 8. So C equal to minus 8 by 5. So all the three parameters I have calculated. Now all the three parameters substitute in this equation. Okay, in this capital first equation I have to substitute it. So when I substitute it, and split the terms. Okay, so now when I substitute it, our question was L inverse of 1 minus s divided by s plus 1 into s squared plus 4s plus 13 was our question. Now it is changed to be L inverse of 1 by 5 is a, s plus 1, split the terms. Okay, L inverse of minus 1 by 5 into s minus 8 by 5 divided by s squared plus 4s plus 13. Okay, 1 by 5 taken outside, so 1 by 5 taken outside, L inverse of 1 divided by s plus 1. Same way, all 1 by 5 I can take it outside, minus 1 by 5 I will take it outside, both minus symbol. So L inverse of s minus plus 8, s plus 8 divided by s squared plus 4s plus 13. Okay, now you have to check. For first, we know that it is a formula. So what is the formula? E to the power minus t is the formula. Okay, for first. Now I have to check it for a second here. So s plus 8 I have, but s squared plus 4 is any shifting I have to apply it. Shifting whether I can apply it, I have to check it. So denominator first I will arrange as per the shifting. So I will check separate. Okay. So denominator I have s squared plus 4s plus 13 I have it. So s plus 2 the whole squared when I write it, s squared plus 4s plus 4. Yes, I can write it. But I have 13 here. But I have only 4 when I write it. Remaining will be, so my s squared plus 4s plus 9 plus 4 13. Okay, wow. So 9 plus 4 is 13. So s plus 2 the whole square plus 9 I can write it. Numerator what I am going to do, s plus 2 only I should have, but already I have 8. So numerator I have s plus numerator I have s plus 8 I have, but I need only s plus 2 for a shifting. So remaining 6 separate I will write it. So now when I arrange and write, okay, now I will use some other color. So 1 by 5 e to the power minus the first subdivision I got answer. Only second subdivision I have to do some simplification. 1 by 5 as it is, L inverse of now s plus 2 1 factor plus 6 denominator how I am writing, x plus 2 the whole squared plus 9 I am going to write it. First you split this term into two parts. Okay, directly I can split it. So 1 by 5 e to the power minus t minus 1 by 5 L inverse of, okay. So L inverse of s plus 2 divided by s plus 2 the whole squared plus 3 squared is 9. So that one plus 6 is a constant. L inverse of I have to write 3 squared means I will write, I will not write 6. So 6 because I have to write a constant formula. So I will have it only 2 outside. 3 into 2 6. So 2 outside, 3 I will have it for writing formula. So now s plus 2 the whole square plus 3 square. So now you check the question. It should be the same question. S plus 2 plus 6. So 8. Same question only I have arranged and written like this way. So now split and write. This is called first shifting property. Both are first shifting property. Okay. So both are first shifting property. I am going to use. So if I use it, nothing but 5 1 by 5 e to the power minus t minus 1 by 5 as it is. First shifting property I use means e to the power 1 divided base plus 2 first shifting property e to the power minus 2t. So e to the power minus 2t, L inverse of remaining posting as it is s divided by s squared plus 3 square. Okay, same way here 2 into e to the power minus 2t shifting property as it is. So 3 divided by s squared plus 3 squared. So now write the formula. So 1 by 5 e to the power minus t minus 1 by 5 e to the power minus 2t. So what is s divided by means cos formula. Any minus symbol, no plus only. So cos 3t. Okay. So plus 2 into e to the power minus 2t. So this is a constant means sin 3t. So now, so whatever term I am able to write it in numerator, I will take commonly 1 by 5 throughout commonly taken outside. Okay, e to the power minus t. In this e to the power minus t minus symbol taken outside, e to the power minus 2t also taken outside. So cos 3t minus plus, okay, 2 sin 3t is our final answer. Okay, this is our final answer for the partial fraction. This is the way we have to do the partial fraction problem. Thank you.